Okay, welcome to your first homework session. We're going to talk about polynomials for our first chapter, and today we have a couple of goals to go over. The first goal is we're going to look at power functions and sketch them, recognize them, and ultimately, if I give you an equation of a power function, you should be able to sketch it and tell me what the end behavior is and if there is any symmetry. Those are new things. We're going to make sure we talk about them here in this video and the next video underneath. So let's get started on your first activity that's going to lead you into discovering what power functions look like. Here's what you're going to do. You're going to graph each of these functions using a graphing calculator. If you've got your own graphing software that you like, use it. Otherwise, I'm going to show you one that's free. It's a website. There's an app for it if you want to get the app for an iPad. But it's free on any computer. I'm going to do it on the computer. What I'd like you to do is make sketches of each of these in your notes and fill in this table also in your notes. And how I'm going to get you started is I'm going to do the first two rows and show you what I'm looking for in terms of degree and end behavior. You'll fill in the symmetry column after watching the next video. So let's get started on graphing these. So what we're going to do is we're going to go to Desmos.com. Now, if you've never used Desmos, just go to Google, type in Desmos, the first one, and you say launch the calculator, and you get this window. And we're going to graph, we said y equals x first. And there's y equals x right there. So what we need to do is fill in the table. Now, since this is just our most basic linear function, it's y equals x, we're going to fill in the degree, the end behavior, and then you'll fill in the symmetry. So let's talk about the degree first of all. The degree is defined to be the value of the highest value exponent. So the only variables here is 1x. Its highest exponent is a 1 on that x. So this is a degree 1 polynomial. Okay, so let's go now define the end behaviors. We have to go look at the graph to do that. All right, here's the graph. So what we're looking for is we define end behavior as what happens when it keeps going way out here and up. Like if it continued, it's going to continue. If it keeps going forever, what does it do? And in polynomials, you'll find that once you start going out somewhere, they just keep going that way. And we have to have a way to write that down. So here's what we're going to do. We're going to write this down. Notice that as x increases, okay, so look at the x-axis. As x goes from 0 to 2 to 4 to 6 to 8, and it keeps going, we want to say what happens to the function, which is the y value, okay, or f of x. What happens to the function? So as x increases, the y's get bigger. That's all that's happening. As x gets bigger, the y's get bigger. Here's how we write it in advanced functions. So for our end behavior, we'll say as x goes out to infinity. Okay, so that's saying as x gets bigger and bigger and bigger and bigger, as x approaches infinity. Okay, the y's, the function itself, we said went up. So the y's also keep going up. So they get closer and closer and closer, or they just get bigger and bigger and bigger and bigger and never stop. So as x goes out to infinity, as x gets bigger and bigger and bigger, the y's get bigger and bigger and bigger. And we needed more space here. I kind of filled that up. But what we also need to do is look at what happens if we look at when x goes out to negative infinity. Okay, so this should fit in this one row. So as x goes out to, I'm going to write negative infinity, and then we'll go look at the graph. All right, so let's look at the graph. Now, how we read this is as starting at 0 is as x goes negative large. So negative 2, negative 4, negative 6, negative 8, negative 10. As x goes out that way, what happens to the function? Does it go up or does it go down? As we read from right to left this time. So as x goes out to negative infinity, the y's going down. So we'd say the y approaches negative infinity. So y approaches, that's an arrow, negative infinity. And that's the end behavior for that first degree polynomial. I'm going to erase it now because I'm going to fill it in for, we're going to go graph the y equals x squared, and we'll graph that, or we'll write that end behavior in. But what I'm going to only erase is the y's, because we always start end behavior by looking at what x does as x goes out to infinity, what happens to the y's, we write it in. As x goes out to negative infinity, what happens to the y's, we'll write it in. So those are the only two things that we're going to modify for the x squared. So I'm going to erase those. Okay, and these come down, so I'm just going to remember these are being written in this box here. Alright, so as let's fill in that the highest exponent here is a 2, so this is a degree 2 polynomial. It's our most basic parabola. So let's go graph it. So I'm going to turn this into Desmos, so I'm going to go y equals x, and then use a little hat, and then that's squared. Okay, so y equals x squared. Okay, so let's talk about the end behavior of this function. So as I said, we always start kind of at the origin. We say, well, as x goes out to infinity, so as x gets bigger, what happens to the function? Is it going up or is it going down? As x goes out to infinity, the y's are all going up. That function keeps getting bigger and bigger and bigger and bigger. So we say, as x goes to infinity, y goes to infinity. So let's go write that in here. So we got as x goes out to infinity, comma, y goes up to infinity. Alright, let's go back and look at when it happens when we go this way. So as x goes out to negative infinity, so as we go negative 2, negative 4, it keeps getting bigger negatively. What is the function doing? Is it going up or is it going down as we go from right to left? It's going up. Okay, so as it goes from x go out to negative infinity, the y's go up to infinity. So the y's approach infinity. Okay, which is different than our first degree polynomials. Okay, so you're going to fill it in for this polynomial, this one, and this one. So you're stating the end behavior, and then you're going to watch the video underneath this one, and it'll talk about symmetry, and then you're going to fill in whether this is point symmetry or it's line symmetry. Check after you fill in this table and then this table, you're going to watch the video underneath that, which takes up this, and we'll talk about the we're looking for some generalizations. We're saying if I show you an equation, can you sketch it?